Hi, I'm Christian,
Hi, I'm also Christian. Welcome to Austria.
where we make renewables more profitable.
Imagine a future where clean energy isn't just generated, it's optimized down to the last kilowatt. A first of its kind project in Austria is looking to do just this by combining wind, solar and battery storage all on one site. The goal is intelligent flexibility, playing multiple energy markets and supporting grid stability all through automation. We traveled to Trumau, near Vienna, to understand how this collaboration between CyberGrid and EVN is redefining what battery storage can do, making the ensemble more profitable than the sum of its parts.
Christian, thank you for having Enlit on the road in Austria. What makes this project so unique?
Pleasure having you. It's the first of its kind in Austria, and it's a battery storage playing all the available market in a co-location setting with wind and PV. So we will be able to have FCR, AFRR, MFRR, as well as day ahead and intraday markets, and of course all the future market that might be coming in the next years. So it all started off when we noticed that we have to switch or curtail our PV and wind turbines many hours a year due to negative prices, and it's of course a shame to drop this renewable energy. So we said we would like to have a storage. The PV curtailment itself is a very good use case, but it does not make the battery storage economically feasible. So what you need to do, you have on the one hand this feed-in optimization, and on the other hand you need to use the battery for multi-marketing. So you need to play on other markets like ancillary services, which gives you additional revenues, and all together you use your system very efficiently and have an economically use case.
What happens if the market becomes oversaturated or if electricity prices swing unfavorably?
I would say there are two aspects. One is if it's on a short term and it's just a day, like we've seen last weekend with basically zero spot prices on the day ahead auction in Germany for the whole day. And the other is on a long-term perspective. On a short term, I would say, a site like this, the battery would operate for balancing services, and maybe the others not, because prices are zero, but still you can do something and you use your very expensive grid connection. On a long-term perspective, if this is all the time, you have to think if there's an arbitrage, is there a difference between the minimum and maximum price? No matter if it's low or higher, you still can leverage this. It's the first time that EVN has on one location wind, PV and a battery storage system. And we did a lot of calculations how they together are more profitable as the sum of the individuals. Now we will operate it and we will see if it really turns out like this. And if so, we have all the experience from operations. We know how to tweak our optimizer. We know what we need to consider more than expected. And then we can roll it out to other locations.
There's so many different distributed, decentralized assets. What are the key challenges in integrating all of them?
So first of all, it's a technical challenge to get all the technical parameters right, handling reactive power on site, handling, for example, thermal issues with the cables and the other parts of the system. But on the other hand, and more importantly for us, it's getting a seamless integration into the existing market to have the project economical feasible. So we try to simplify the complexity here and use the combined asset to play all the market and to earn its return on invest, basically.
What are some of the key stress points or vulnerabilities in the power system that the system is designed for?
So the grid operator provides us with the necessary markets, and we try to bid on these markets. So there is ancillary services, it supports frequency control, and we bid the assets on this market. There will be in the future, we have the network codes for demand response on a European level, so there might also be a distribution grid market where we solve thermal issues or even voltage issues.
Would you say this is a blueprint for other companies looking to do the same?
It can be, and it will be. So for our company, we are also active in Southeast Europe as EVN. We use it as a blueprint within the company. So there are some bigger projects to come that will have basically the same concept.
In the future, when more of these projects come online, what will separate the successes from the failures?
So at the moment, the whole machine around it is very, very complex. We play a lot of markets. And the key point is to make it user-friendly, to simplify this whole technical policy complexity. So a user, a trader, an operator can use the whole system very efficiently and very easy.
I want to go back to connecting all of these different assets. Is there communication challenges that you experience across all of them?
Of course, so on the one hand, there is cybersecurity. It's something we have our guidelines for. And on the other hand, there are many departments, many systems that need to interact with each other. And communication between the system is the key to build a robust network.
I'd like you to walk us through a bit of a scenario. There's high levels of PV, high levels of wind, but power demand on the grid is quite low. What is the almost technical process of the battery choosing to store, charge or discharge to and from the power grid?
The process basically starts every day in the morning for the next day. So we have a lot of decisions that has to be done day ahead, starting with FCR and AFRR. So if we predict good prices or a good chance to use the battery on these markets, we bid there, getting to day ahead wholesale markets, getting into the intraday market, and getting into very short-term ancillary services markets. It's called energy bids. And what we try to do, we basically have our process in place, starting at 8 o'clock in the morning and going over the whole day, over all markets, continuously through the next day. We have forecasts for price, for power generation, for overall state of the system. And this all combined gives us a good picture what to do with the battery the next day or the next minute or the next 15 minutes.
In operation, we have forecasts and we have real measurements. We have an optimization. They consider this. And based off that, basically, we would decide to charge the battery, or we would even say, no, we won't charge the battery. We will wait for charge the battery while also doing balancing service. This is running all the time, during the weekend, during the night. Basically, it runs automatically. So there's no people sitting there. We are analyzing the behavior, but in operation, that's all automated.
We also were kind of an early mover when it comes to policy, when it comes to get all the permits for this project. I think there will be some crucial insights and some question marks also on our side. How is the battery behaving in different weather conditions? Are our forecasts right? Can we do better forecasts with more data? I assume yes. But the next year basically will tell which data we can use for operations or for better operations.
Christian, thank you so much for your insights. For more insights, join the Enlit community.